Let's lay the foundation. In this section, we'll define artificial intelligence, walk through how traditional AI works and where it hits a wall, and then draw a crisp line between machine learning and deep learning. Those last two get tossed around like they're the same thing. They're not. And on the exam, that distinction matters. Here we go. Okay, let's start right at the beginning. What is artificial intelligence really? Look at the center of the slide, those nested rings, because that picture is the mental map for this entire course. The big outer ring is artificial intelligence. Any system doing something that normally takes human smarts. Recognizing a picture, understanding language, making a decision. Step 1, ring inside and you hit machine learning, where systems learn patterns from data instead of being explicitly programmed for every case. Go one ring deeper and there's deep learning, neural networks with many stacked layers that learn really complex patterns on their own. And glowing right at the core, the newest and fastest growing branch, generative AI, which creates brand new content. AI, then ML, then deep learning, then generative. Burn those rings into memory because we hang everything else in this course on them. Now here's why you, sitting in the infrastructure seat, should care. And it's the entire right side of this slide. Every one of those branches leans on your gear differently. Read it top to bottom. Plain AI runs broad workloads on balanced compute and ordinary networking. Machine learning steps it up, CPU and GPU, large data sets, reliable high throughput networking. Deep learning jumps again to high performance GPUs, massive data throughput, and a low latency lossless fabric. And generative AI down at the bottom demands massive GPU clusters, extreme compute, and tiered high capacity storage. See the pattern? As you move inward toward generative AI, the infrastructure demand climbs hard. More GPU, more bandwidth, more storage, every step. Think of it like vehicles. Traditional AI is a commuter car, gets the job done, sips fuel, parks anywhere. A deep learning training job is a fully loaded 18-wheeler. It needs a different road, a different fuel budget, a whole different plan. Same family of transportation, wildly different demands on the infrastructure underneath. So here's your takeaway, and it's the foundation for everything ahead. The moment someone tells you what kind of AI they're running, you should immediately start hearing what it'll cost you in compute, network, and storage. That instinct translating the workload into the gear is exactly what this certification is testing. Lock in those rings and that right-hand ladder, and you're already thinking like an AI infrastructure pro. Before the deep learning hype train, we had traditional AI, and here's the thing, it's still running all over your network today. Follow the flow across the top of the slide because it's beautifully simple. Step 1, input data, raw transactions, logs, sensor readings, whatever's coming in. Step 2, rules and logic. And notice it's literally if condition A and condition B, then take action. Predefined rules, business logic, a statistical model. Step 3, out the other side comes a decision or classification. Approve, flag, reject. Data in, rules applied, decision out. That's traditional AI in one breath. Now look at those 4 callouts across the middle, because they're exactly why this approach refuses to die. It's deterministic and explainable, and that's a big deal. You can trace every single decision straight back to the rule that made it. When an auditor or a regulator asks, why did the system decline this one? You've got a clean, defensible answer. It's great for well-defined, stable problems where the rules are clear. It's reliable and predictable. Same input, same output, every single time. And it's easy to govern and update. Try squeezing that kind of transparency out of a giant neural network. You can't, and in regulated industries that matters enormously. Check out the examples along the bottom. Fraud rules flagging a weird transaction, recommendation filters, routing logic deciding where traffic goes, classic statistical models for forecasting. Think of traditional AI like a sharp front desk clerk working from a rule book. fast, consistent, and they can always tell you exactly which rule they followed. What they can't do is improvise when something totally new walks in the door. And that's the crack in the armor. The moment the data gets messy or the situation keeps shifting, a rigid rulebook starts to creak. And that's the exact gap machine learning was built to fill, which is precisely where we're headed next. For now, lock in this picture: input, rules, decision, deterministic, and explainable. The exam loves explainable as the signature word for traditional AI. So tuck that one away. So if traditional AI is so reliable, why isn't it the whole story? Look at the left column. 3 key challenges, and they're the reason deep learning had to come along. 1. It struggles with unstructured data. Handed images, speech, or freeform text, and a rulebook falls apart. There's no clean if-then for a photo. 2. Rules don't scale. Every new edge case means writing yet another rule, and before long you've got a tangle nobody can maintain. 3. It's brittle. Change the environment and the rules that worked yesterday break today. But, and this matters, look at the right side. Still vital real-world applications. Do not write traditional AI off. It's doing serious mission-critical work right now. In networking, routing switching, traffic policies, configuration. In finance, transaction rules, compliance checks, fraud detection. In manufacturing, process automation PLC logic, safety interlocks, plus aerospace, healthcare, telecom, utilities. Anywhere you need predictable, explainable, bulletproof behavior, those deterministic rules are exactly what you want. So which do you pick? Here's the move the pros make, and it's right there along the bottom. You don't pick, you combine them. Traditional AI's rules and logic plus machine learning's data-driven pattern finding equals hybrid intelligence. Let the rock-solid rules handle the clear-cut regulated cases and bring in machine learning for the fuzzy, messy, ever-changing stuff. With a human still in the loop, think of it like a seasoned help desk. The rulebook handles routine tickets instantly and consistently. The experienced human, that's your ML, takes the weird, never-seen-this-before cases. Together they beat either one alone. That hybrid pattern is everywhere in modern data centers, and it's a great instinct to carry into your designs. Don't think old versus new. Think right tool for each part of the job. All right, now let's draw the sharper line between machine learning and deep learning.